For our project, we created a user interface that allows users to select between variational autoencoders and GAN models to create always positive polynomials. We only need one parameter, which is for the degree of the polynomial to be generated. This cannot be an odd number because odd degree polynomials intersect with the x-axis at least once. So let's try 10. As you can see, this is our variational autoencoder training. This is our training accuracy, this is training loss, validation loss, and validation accuracy. As you can see, it gave us an always positive polynomial. And we can copy its LaTeX code like this. So there's a maximum allowed degree, an upper bound. How do we decide on that? For that, let's open our dataset. Here, as you can see, we want to create 14 degrees polynomial, for example. There are 6 instances of 14 degree polynomials in our dataset. We decide on a rule that if we want our model to create a polynomial with n degree, at least 25 instances of n degree polynomials must be in our dataset. This is because we want our model to be accurate and we want it to be able to generate more creative polynomials. So we look for 14 here, which has 6 instances. So we cannot create 14 degree polynomials just by our model. Then we look for 12. We call this fallback degree method. And there are 2 polynomials with 12. We cannot create it 2. Then we look for 10. As you can see, we have at least 25 instances of 10 degree polynomials. So we will use 10 degree polynomials to train our model, which ends up with generating a 10 degree polynomial. But what we asked was a 14 degree polynomial. So we have 4 coefficients that are not assigned to any number yet. To solve this issue, we randomly generate numbers using NumPy random function, and we check for positivity of the 14 degree polynomial at each step. So if it's positive, then we return it and save it into our dataset. So after creating 14 degree polynomials 25 times by this method, so then we will have at least 25 instances of 14 degree polynomials in our dataset, which means after that our model will be capable of generating a 14 degree polynomial by itself. So then maximum allowed degree will be 18. So then we will be able to generate 18 degree polynomials, and it will go like this. So our model will improve itself. So the upper bound is fallback degree plus 4. And this is our GAN part. As you can see, this is training of GAN, and this is the polynomial. GAN doesn't have the fallback degree methods implemented, and what we can say is variational autoencoders were much more accurate than GAN models.